While the power of quantum computers is growing with every single new release of the quantum computing companies, at the same time, the requirements that the algorithms actually have in terms of what the quantum computer needs to offer, number of gates, number of qubits, is getting smaller and smaller with every new algorithmic breakthrough. And that, of course, leads to the question, when do quantum computers actually become useful, and what are the problems that those computers can be applied to in a meaningful manner? And one of the companies that is dealing with applications running on quantum computers is QunaSys, which is the company that we are talking about in today's video. So if you want to learn more about what they're actually doing and what are the applications that they are looking into, that they are working on, and where potentially quantum computers might in the closer future already offer some advantage, then stay tuned for today's video as we are diving deeper in QunaSys. And with that, let's get started. Here we are on their website, and it says maximize the power of quantum computing, so expanding application frontiers and building practical foundations. QunaSys turns quantum computing into new industrial value by tackling real-world industry challenges, driving breakthrough innovations, and shaping the future. And then we see the logo over here, as well as some press releases. I'm recording this in June of 2026, and you can see here that you have some releases from May. So I would say it's reasonably and very much up to date. Here we have the case studies, and I want to dive deeper in today's video into some of those to actually understand what, let's say, are the applications that they are looking into, and probably the ones that you might also be interested in looking into if you are thinking about, let's say, adding a quantum component to your existing solution portfolio. But we will save that for a moment. Then there is some information here about the offers. As you probably can already infer from what I said previously, the company is in the solution space. So we see that we have the algorithm and software component in here, potentially also the business-driven component. So for companies exploring quantum-driven business transformation, quantum algorithms and software, an SDK, which is called Curie SDK. So curious. And then we also see the R&D department and chemical industry revolutionizing materials development. Again, here's the news section. Then there are some publications, so they're also active in the scientific space. Some insights which probably go deeper into specific elements. You see the team over here. We will look at that, of course, as per usual at the very end. And then some contact information. The company is based out of Tokyo in Japan, but they also have an office in Copenhagen in Denmark. What is also important is they are hardware agnostic, so you can run their solutions on various different systems. That includes, of course, the big ones like IBM Quantum, but also the more recent platforms like, for example, IonQ, QEra, which of course we have also already created videos on. If you haven't seen those, then go check out our Hidden Quantum Champions playlist on the YouTube channel. And with that, I mean, we are at the very end. You see the services, the resources, and so on and so forth down here. Now, let's quickly explore the case studies that they have listed here. And then we go into one of them, or maybe two of them, into a little bit deeper. So the first one is with Toyota Central R&D Labs. It's quantum dynamic simulation. Quantum dynamic solutions are a method that allow for more accurate describing natural phenomena by taking into account the quantum effects. So that's, let's say, on a more top level, the explanation. What this is there for is down here. So this is expected to change the way materials design works, particularly in areas such as functional optical materials and catalyst design, which of course is interesting for Toyota. I mean, catalysts in gas cars and then functional optical components for various different things, communication, and so on. Then we see here ENEOS Corporation, so frequency analysis of the molecular vibrations. Frequency analysis of the molecular vibrations is a fundamental method of chemical analysis and is used as a spectrum of evaluating the mechanism of mechanical reactions. And then there's some more information about this here as well. It is especially holds a prominent position among the energy fields, such as analyzing catalytic reactions of petroleum refinement, so again related to gas, right, and hydrogen production, and reaction analysis of all additive from lubricant oils. So you see that very much caters into the, let's say, oil industry or into the petrochemical chain of value, right? Then we see down here basic methods of quantum chemical calculations. So again, that is more on the R&D side. Let's hop back again, because I thought there's some more information also here, right? So funded by European Union, you see that this collaboration between Denmark and Japan, right? As quantum algorithms experts in the Horizon Grant backed full map project, we are advancing battery innovation for real-world development through advanced materials design and evaluation methods. Then Innovation Fund of Denmark, right? As part of the Innovation Fund Denmark backed Hyper 10Q project, QunaSys is advancing quantum computing for chemistry to accelerate breakthroughs in material science, drug discovery, and sustainable technologies, which are, I think, very much at the base, at the heart of Denmark's values, right? You do have this sustainable thought. If you are ever flying into Denmark, you will see, like when the aircraft is descending, you will see that there's a lot of wind power, a wind power park close to the shore. Generally, I think the Danish people are very connected to nature, so there's this sustainable technology thought, but at the same time also drug discovery plays a big role. Novo Nordisk is one of the companies that is based in Denmark, one of the also pharma giants in today's world, so that's definitely also important, and material science as well. Then we see IBM Quantum here. So we provide quantum chemistry calculation services powered by our proprietary high-performance algorithms delivered for the IBM Quantum platform. Then we see SIP, so Cross-Ministerial Strategic Innovation Promotion Program. We are building a high-precision quantum computing infrastructure and internationally aligned algorithm platform while establishing a quantum classical hybrid environment through RIKEN's National Testbed Project. RIKEN is a famous research center from Japan. Then we see Fujitsu, of course. We have developed a versatile quantum algorithm with potential applications in solid-state material development. Then we see ENEOS. We have successfully demonstrated a method to analyzing molecular vibrational spectra, a key factor in the energy sector, using a real quantum computer. And then we are back to the beginning again. Now let's focus on that one here, on the frequency, and see what we can learn here. So frequency analysis of the molecular vibration is a fundamental method. I think we've gone through that already. However, frequency analysis were difficult to process on classical computers and were behind on industrial applications. The ENEOS group and QunaSys has collaborated to approach this challenge by working on the development of quantum algorithms and verified on the actual Honeywell quantum computer. And there's more information here on this blog article, which let's quickly try to check this one out to see what else we can learn about that. Of course, while this is loading, I will use that as a little self-advertisement. So if you're interested in quantum technology from a commercial point of view, so if you are, for example, leading an R&D department, if you are managing the R&D sector of your company, if you are a founder of a quantum technology company yourself and you want to, let's say, explore a little bit what is out there, or if you are a supplier to the quantum market and you want to find new potential customers, then I might have something for you. Go check out the video description. We are launching a very interesting product, or have launched an interesting product. Go check it out in the video description. Now back to the video. So this is still loading as it seems. Let's try to reload this again. It seems like this is not really leading us to... now it's working. Okay, here we are. So explore today's quantum systems with Azure Quantum. So now we are on the Azure block, but of course this is still with the QunaSys algorithm development. So companies and application partners are opening up new avenues for research using Azure Quantum to experiment building and running quantum algorithms on leading quantum hardware from Honeywell Quantum Solutions and IonQ. So basically this Azure Quantum platform, I've also done, when they launched it, they also offered a workshop and I've participated in that many years ago already. And the idea was that, okay, Microsoft is not only, let's say, doing fundamental research with their Majorana chips and so on to build their own quantum solution, but they also have a cloud business where they basically allow third-party players like, for example, IonQ, like Honeywell Quantum Solutions, to actually put their machines onto the cloud and give people access to that. So basically expanding on the existing Azure or Azure cloud business by adding quantum to this high performance compute. Okay, back to the text. One of the challenges in quantum computing is understanding where the practical impact will be as hardware capabilities mature. At this week's Microsoft Build, Microsoft's Maya Mukaiola explains the important role our quantum software development tools play in researching and testing quantum algorithms on quantum hardware through Azure Quantum to help developers build skills in the critical area. Maria breaks down the hybrid quantum software development workflows into steps, explaining each step related tools in detail, many of which a classical developer will find familiar. So at Microsoft Build, Brian Nienhuis from Honeywell Quantum Systems will also share how Japan's largest oil company, ENEOS, and Microsoft Quantum Network partner QunaSys use Honeywell's trapped ion system for practical quantum chemistry research. Vibration spectrums are used to identify chemical compounds, understand equilibrium and transitional structures in chemical reactions, and understand thermodynamic quantities like free energy. So that is like entropy. This is a defined, let's say, a defined value from the world of thermodynamics or quantum thermodynamics or quantum statistics, so large systems of quantum objects. Their experiment simulates the molecular vibration modes of water and methanol, showing agreement between the quantum simulation and the known values. These two types of experiments performed on systems available today help determine what future scale-up systems can accomplish with bigger problems. We can take this knowledge forward as more scalable quantum hardware becomes available. Be sure to view the full Microsoft Build session, link is over here, for this. So basically, if I understand it correctly, and this is from 2021, so this is, let's say, not the latest and greatest information. What they've been doing here is they looked at water, they looked at methanol, and they tried to extract these vibration states. So what do we mean by these vibration states? If you think about water, for example, H2O, so 2 hydrogen and 1 oxygen atom that are bound in this molecular kind of triangle, right? Now the center is the oxygen, and then you have the 2 hydrogen dangling bonds over there, and those, they can vibrate in different modes, right? You can, for example, have them vibrate like this, or you could have them vibrate like this towards the atom on the top of this pyramid, right? So there are different vibration modes. These different vibration modes, they are associated with different energies. So they're of course quantized because we're in the world of quantum. So they have specific energy levels associated with them. And these, they can absorb specific frequencies. And that's, from my understanding, what this is about. So this is trying to extract those vibration states. And then they're doing this for known molecules like water, and I think the other one was methanol, right? But of course, when we are looking at all these petrochemicals, things are much more complex. You have these rings, the like more complex compounds, long chain oils and short chain ones. So there are various different compounds that you try to also distill that kind of end up in your gas or end up in an aircraft jet engine for different levels of this distillation stages. And as far as I understand this, the idea is to start with these easy molecules, compare them to existing calculations that we know are correct, and then basically be able to infer how much more powerful the machine needs to be to do that for something useful, like, for example, oil. And that was in 2021. So I assume that now, 5 years later, there might be more possible than just looking at water molecules. But yeah, I'm not an expert. I've not been involved into any of these research activities, so I don't know. But looking at this, it seems they're also looking into other directions like batteries, right? Like material research and so on and so forth. Very quickly, about their services. So they are active in 3 different domains. One of them is in the research domain, so drive business change with quantum computing. And that refers to, let's say, what we just saw, right? Like running algorithms on machines for specific problems, but then also publishing research papers themselves, right? We've seen that they have also been active in the publication. Then there's the software side. We've seen that before, right? There are software packages available, advanced quantum algorithms and software R&D. And then the third one is the consulting part, where they basically, consult you. They can hop in as an external R&D team and support with your quantum R&D in a specific case. So redefine materials development mentioned there as an example. What are the topics they're looking into? Well, chemical simulation is what we just talked about. Battery material simulation is what we've seen. Condensed matter simulation goes in the direction of materials research, which we've also seen with this Danish fund, right? Same for the faster drug discovery. Then there's computer-aided engineering. That part we have not touched so much yet. And the catalyst design, which we've also seen with Toyota before, right? Then there's more information down here about the different layers, right? Hardware, we've seen that, for example, this is being hosted on the hyperscalers like Azure Quantum, but we've also seen other individual providers like PsiQuantum on the original slide with all the partners on there. Then we have the EFTQC architecture. So I guess this is the quantum computing architecture, so the actual quantum computers. Then we have the quantum circuit, which is basically the algorithm, so the different gates that you're running that then compose into the algorithm. Algorithm might also include that you have part of your solution running on the quantum computer, another part on a classical computer, like in a variational quantum eigensolver, I guess. And then there's, of course, the application layer, how this actually gets implemented into your application, for example, in finding the vibrational states of a molecule. And that's kind of how their solutions tie into that. So you have the Curie parts, fundamental building blocks for Curie SDK. Then you have the Curie algo, so the algorithm side, right? Ready to use algorithm components and framework. And the Curie VM, I guess like virtual machine architecture, device abstraction, analysis, optimization, simulation, and execution on the actual hardware. That's how they kind of tie into the overall workflow. So how the overall workflow works. You start with an hypothesis that you, of course, at the end want to verify or falsify. Then you have the structure, target identification, conceptual modeling, mathematical modeling, the actual computation. That's where their SDK comes in. And then, of course, the analysis and interpretation. What I found interesting here is that this QunaSys also mentioned something here regarding large language models and scientific knowledge. So it seems like in the structural research, they are also using these machine learning approaches, databases, maybe also proprietary databases to guide this process of the structural analysis. Besides the SDK that we've talked about, there's also this community here, QPark. So it's a research community. So if you are, let's say, part of the quantum algorithm research community, either in Europe or in Japan, this might be an interesting thing to look into, user community. And then there's the SDQs, so shaping the future with quantum and ESG, available here as well, or to learn about as well. And then what I also found interesting, because of course we're always interested in education, there's this Quantum Native Dojo, which is a, let's say, a book, more or less, like an online version of a book, which you can go through and you can learn about quantum over there, as well as this quantum circuit simulator available here as well. You can download it from GitHub. With that, we are moving towards the end of today's video. I don't want to make it too long, but I still want to show a little bit about the company, right? Because now today we have a Japanese player, which I think I haven't highlighted too many of yet in this series. So also want to put a bit of a focus on that. So QunaSys was founded to bring quantum physics, which has thus far supports current technology behind the scenes to the foreground, and achieved what existing technologies have not been able to accomplish by utilizing the quantum nature of matters. While advances in hardware are essential for practical applications of quantum computers, advances in algorithms and software are key to making the technology truly usable. QunaSys provides algorithms and software to maximize the performance of quantum computers, thereby contributing to the social implementation of quantum computers. QunaSys provides solutions that can actually be used in your business, combining the research capabilities to solve problems for industrial applications with the development capabilities necessary for the practical use of quantum computers. Here we have the company overview, founded in 2018 with locations or offices in Tokyo and Copenhagen, as well as the team. I guess that's the board of directors and maybe the board member team. There's also some information here about the individual members of that team available as well. So you have on the one side the Japanese team / CEO and co-founder, as well as the, let's say, European side of the team. And then, you have the advisory board as well. So the company, I would say, is still very focused on the hard science part. So you see the team is still, very, very focused, very dense. There's not a lot of people in there yet, but also that might not even be necessary, because if you're working on the algorithm side, if you're working on the software side, even with a very small team, you can reach very large goals. You've seen that with the recent developments in machine learning technology. If you're looking at, let's say, the big companies in the language model space, like OpenAI, like other ones, whatever LLM you are using, the teams behind those, they're usually not extremely huge. At least at the beginning, they were not. Of course, now this is scaling with the interest of the market. But that said, on the software side, you might not need a super large team at the very beginning, but you can still reach meaningful goals. With that, I want to wrap up today's video about QunaSys. I hope you liked that. I hope I didn't completely mispronounce everything here. If you want to watch, or let's say if you found this interesting, then make sure to subscribe to the channel so you can watch also the next videos that might be interesting to you. As always, make sure to stay hydrated. Summer is coming, and I'm looking forward to see you in the next video. Until then, bye-bye.